Hi there, and welcome to this video on inequalities. I always put at the start of my videos to like this video if you find it helpful, subscribe for more math help, and drop a comment or question for me below. Now, this video is technically bridging a content gap. So I looked at the material to begin a study on inequalities, and what I thought I saw was too much material for one lesson. And what I want to do in this video is focus on the inequality symbol. This is often a very, very misunderstood concept coming out of elementary school and is worth reviewing in detail. I've seen so many students with so many misconceptions about it. And as soon as we move from equations to inequalities, there's this shutting down of, I don't understand that symbol. And to be fair, I have sat in on and watched video lectures of people at the elementary level explaining this and thought to myself, my word, now I know why kids are so confused about it, because I thought they took a pretty straightforward concept and made it sound really hard. So rather than cram everything into one big lesson on solving linear inequalities, we're going to take some time and just focus on the inequality symbol. And I'll add this video to multiple playlists because I think this is a review that can come at a lot of different places in your math journey. Now, first off, the inequality symbol is this symbol right here. Okay. And so it's sometimes described as like the alligator. I've seen like a lot of different ways, but it looks like that. Mine are kind of asymmetrical there, but I think you've seen them before if you're taking an Algebra 1 course. You've seen those. I don't know when they first turn up in math because elementary math is not my forte, but I know they show up fairly early on. Now, it is the same symbol, but it can be flipped in either direction. And the first misconception I want to address in this video is that those are two different symbols, and one of them is the less than symbol and one of them is the greater than symbol. It is the same symbol, and it can be flipped in either direction depending on whether the quantities you're looking at are bigger or smaller. It always opens to the larger quantity and points to the smaller quantity. So I've seen the most common one is like the alligator, and the alligator's hungry, and so the alligator always wants to eat the big amount of food because the alligator is super hungry. And so if the big number is on the right, then the symbol will be opening to the right. If the big number is on the left, then it'll be opening to the left. And then I've also seen students do the hold up your hands and like make the letter L, and like the letter L, if it looks like sort of like a messed up L, then it's the less than symbol in that, and you read it. And all of those things are helpful, especially the part about like what's big and what's small. But it also kind of lends to this misconception that you've got a less than symbol and you've got a greater than symbol, and you've got to use tricks to figure out how to read it out loud. And so that is what I want to dispel in this lesson here. So looking at this expression, you can see it's x is less than 5. And the reason I read it as x is less than 5 is if I'm reading from left to right, I can see that the symbol is pointing towards the x and opening to the 5, which means that 5 is bigger than whatever x is. So as I read it from left to right, I would read it as x is less than 5. But you can also look at that same expression and say 5 is greater than x. So 5 is greater than x. So you could read it from right to left. And if you read it from right to left, now you're starting with the bigger quantity. So you would say 5 is greater than x. Okay. And so you could read that expression both ways. Also works in the other direction. Okay. So we could read this as x is greater than -3 because it's opening to the x, which means that the x has to be the bigger quantity. So the way I would read it is x is greater than -3. But if you were to read it from right to left, you would say -3 is less than x. Okay. And so again, it's the same symbol. how you read it out loud just kind of depends on which direction you're going. Now, we typically read from left to right. So you might be thinking, well, why is she like reversing the direction on that? Well, because I can. But typically we would read this from left to right. We would say x is less than 5 or x is greater than -3. But don't confuse that with there being two different symbols. It is one symbol that is read aloud in two different ways, depending on how you're hitting the symbol. So if you hit the pointy end first, you would read it as less than, and it doesn't matter whether you're reading from left to right or from right to left. If you're hitting the pointy end first, it's less than. If you're hitting the open end first, then you know that whatever you just read is the bigger, so you would say is greater than. And again, it doesn't matter if you're reading from left to right or right to left. Again, I'm always going to read it from left to right unless I have some reason to read it the other way. But again, you could, okay? You could read it the other way. So graphing in one variable, all that means is that we're graphing something that only has an x in it as opposed to an x and a y. Now we will graph these in two variables where you have an x and a y, but that's not where we start. We're going to start with graphing it in one variable. Now this is a key concept, and if you're taking notes, this is something you should write down. And we've talked about this before in this video series because it's one of those foundational concepts of what we're doing when we're graphing. We always shade or color in the solutions. That's what graphs are. They are visual representations of the solutions. And we've looked at graphing them on a number line, and we've looked at that coordinate plane where we have pairs of x's and y's that satisfy an equation and make it true. So that is what we place a dot on every point that makes the equation or inequality true. That's what it means to be a solution. And so if it makes it true, you put a dot there, and that represents part of the graph. So let's consider x is less than 5. I want you to think about this. How many solutions are there? That is, how many points can you think of that would make that inequality true? I'll let you kind of think about that for a moment. Okay, so we have like 4 is less than 5. Okay, and we know that's true. And so we would go and put a dot at the 4 because 4 is less than 5. And you might say, oh, well, 3 is less than 5. And so that is another solution. So we have another solution there. Okay, there we go. And we could keep going, like 2 is less than 5. And I think you see where we're headed with this. Don't forget 0. Okay. Students like to forget that 0 is on the number line, but 0, negative numbers. Okay, so -1 is less than 5, so we could go into those negative numbers. Now, decimals also work. Okay, so you could say -2.5 is less than 5. So that would be right there in between the -2 and the 3. Now, here's where it gets a little more interesting. We said 4 is less than 5, but now that we've thought, oh, look, what about decimals? 4.5 is less than 5. And that would be halfway, but 4.9 is also less than 5. And then what you realize here is that we're getting awfully close to that 5. In fact, we have like 4.999, like that is also less than 5. And so we're getting really, really, really close to that 5. But 5 is not less than 5. Okay, that doesn't even make sense that 5 is less than 5. That can't be less than itself. So not the 5, but getting really, really close to it. And what you might have noticed is that all of the dots that we put in there are all on one side of the 5, and we certainly did not come up with an exhaustive list of all the numbers. So what we can see from this is we can see that there are an infinite number of solutions. We could keep doing this forever. If there, you could just keep generating more and more numbers that are less than 5, and they get infinitely close to the 5, meaning we have like 4.9 and 4.99 and 4.999 and 4.99999, whatever, however many nines you'd like to have there, that would be less than 5, but not the actual 5. So we're getting closer and closer to that 5. So now the question becomes, how can we create an efficient graph with this? So what we do is, instead of plotting an infinite number of points, we simply shade in the region where those points exist. This is the same way we do when we graph a line. Okay, we've got an infinite number of points that will make the equation true, and we might plot a couple of them as dots so we can anchor the line in place, and then we just draw a line in. So if I know that it's all of the points to the left of the 5, I'll just do something like this. And I've seen different versions of that where people like shade it in different ways. I usually just take a pen and just kind of color over the line because I know that's where all the points are, like all of those points going forever to the left. We also need a way to indicate that we get closer and closer to the 5, but do not include the 5. So that gets a little bit trickier. And what's important to remember is that key concept is we shade in the numbers or values that are solutions. So that gives us our solution to this problem. We do this using an unshaded dot. It marks the boundary, but shows us that the boundary is not included. So the 5 represents this boundary, but the 5 itself is not a solution. So remember that we shade solutions. So what we do is we put a dot there and we don't shade it. So we've got our shading, and our shading is going to go right up to the dot, but it's not going to include the dot. And that's our way of marking the boundary without including it. Way too many students just try to memorize, like, oh, if it's got the no line under it, then I use an open circle. We'll get to that in a moment. And they try to memorize that rule without anchoring that rule in the key concept. We shade the things that are solutions. So if 5 is not less than 5, that's not a solution, and so you would leave it unshaded. You just have to find a way to mark that boundary so that you're not crossing it with all your 4.99999s. All right, be cautious of negatives, and I just say this because it can be an issue. X is greater than -3, and I've seen so many students say, oh, -4, -5, and what they're doing is like just kind of making the 3 like bigger, except it's negative, so it's on the other side of the number line. So numbers that are greater than -3, that would be like 5 is greater than -3, and that can like let you know which side of the 3 you're on. But essentially, it's going to be all of the numbers over there, and the 3 is not included. -3 cannot be greater than itself, and so we would put that open or unshaded circle there and shade everything to the right and say, okay, those are our solutions. Greater than numbers are always to the right, less than numbers are always to the left. That's easier for most students to see in the positive numbers, that as you move to the right, they get bigger, and as you move to the left, they get smaller. The negatives kind of mess with our brains a little bit, but it's still true that as you move to the left, the right, they are bigger, and to the left, they are smaller. Make sure that my mouth and the little dot on the screen are doing the same thing there. All right, now what if we need to include the endpoint? And I decided to do this with an example. For example, I teach some classes that have these special tests that we take, industry certification tests, and a student needs a score of 700 or higher, okay? And the scores range from, I've only seen them go into the 300s, but presumably they go lower than that. I've just only seen them go down like into the 300s. But a 700 is included as a passing score, and I have had students pass on a 700. The first one I took, I passed on a 700. Anything below a 700, you have a 699, you're not passing. And so if you want to include that, so we know scores above 700 would all pass. And my pen is doing really weird things. Okay, but this time we want to include the 700. In other words, X has to be greater than or equal to 700. And I've had so many students say, well, it can't be greater than and equal to. True, like it can't be greater than and equal to, but it could be greater than or equal to. So a student that gets a 715 passes, and a student that gets a 700 also passes, like one or the other, like both of them work. And so remember the key idea. We shade the solutions. So if we need the endpoint as a solution, all we do is shade it. And so instead of having a unshaded dot as the endpoint, we would simply shade it. And again, it goes back to that key idea. We always shade the things that are solutions. So you should not be trying to memorize something like, if it's got the line under it, then I color it in. And if it doesn't have the line under it, I don't. We want to remember what that line represents. It represents essentially the bottom half of an equal sign. It means or equal to. And if it could be equal to, then it is included in our solution. And so we shade solution. That's why we're shading it. Okay, hopefully that clears up that misconception. So what are some variations that you might see on this? So this one I've actually been doing during the lesson, and I've tried not to do it. But shaded dot is often called a closed circle. So instead of shaded or unshaded or colored or uncolored, you'll see the word closed. Okay, and an unshaded dot is often called an open circle. Okay, so just so you'll know, like you see that closed and open. And open is kind of visually, you can see it there, like open, like the inside is open, where as opposed to closed, like it's shaded in. Now, there are some interesting variations on the symbols that you can also see. So instead of dots, you may see a bracket for a closed circle and a parenthesis for an open circle. So I'll show you what I mean by that. In this problem here, we've got x is greater than 7. And so you could see this open circle with the shading to the right. But I have seen this where there is a parenthesis right there, parenthesis right there instead. And so it's like your parenthesis there, parentheses, it's like that symbol there. X is less than or equal to -1. We would use the closed circle there. And it's less than, so we're shading to the left. But I have seen this, and it's like a square bracket that is used right there instead. Sorry, that's like not super clear. What I'm trying to draw there is that symbol. Okay, and there's a good reason for that. There's another kind of notation that you learn later on, usually in Algebra 2 or pre-calculus, one or the other, that will use the parenthesis and bracket notation with it. And so it's a way for teachers kind of to prepare students to see that symbol a little bit earlier. So you might have a teacher that is doing that instead of the circles, okay? But they mean the same thing. So that's one of the variations. Now, because this is essentially, I'm doing this in an Algebra 1 video set, but it's pre-Algebra 1 material. I did not do a separate practice set for this video. So what I do need to do here, though, is write the inequalities. So you can pause the video, but I need to do these out by hand. It won't take a moment. And go. And the last one is, okay. So pause the video for a moment, take a look at these, graph them out, and then unpause it, and I will go over them real quick. Okay, so for this first one, this is x is less than 5. And you'll notice that I only put like the number that I care about on my number line. I am not doing like counting out like left and right. I'm really going bare bones here. X is less than is going to be to the left, and it is less than 5. It is not including the 5, so that is an open circle. X is less than or equal to -2, so the less than would be all of these numbers, and or equal to the -2 means that we will close the circle. We'll shade that in. X is greater than or equal to 4. Well, greater than numbers are over here to the right, and the 4 is included as a possible solution. So that would be a closed circle. And x is greater than 0. Greater than, of course, is still to the right, and now we would use the open circle there. For this one, write the inequality where you can tell that we're shading off to the right, so that's going to be greater than. So that's x is greater than 2. This one is tricky, and that's because I like to push the boundaries in my practice sets, like just see what you'll do with it. So we're looking for numbers that are in between -3 and 0, but the -3 is not included. And so the way you would write that is you would use the inequality without the equal sign because it's not included for the -3, and you'd use one with the equal sign for the 0. And you would read that -3 is less than x is less than or equal to 0. You could also do that with this. X is greater than -3, and also x is less than or equal to 0. So you can do that with the word and also. And if you're wondering, well, she didn't talk about that in this lesson. No, I didn't. But that's because I want to just see what you can do with it. Like, what would you do? How can you put something together? If you got it partly right, rock and roll, keep going. And this last one is to just look at that other notation. And this would be x is less than or equal to -3. So that bracket means that it's like the same as the closed circle. So just so you can see that other notation. All right. So hopefully that gave you a really, really good refresher on inequalities, cleared up some stuff that was maybe confusing, and showed you something new. Please don't forget, give the video a thumbs up if you found this helpful. Subscribe for more math help. Drop a comment below. Even let me know what you'd like to see a video on. And check out some of the other videos and playlists on the channel for different levels of math. And I will see you in the next video.